Welcome to the Unboxing Technology series by Digitarati. This video is on Hazelcast.
Shop is all about giving you an insight about this product called Hazelcast. What are the various products which Hazelcast offers and how you can leverage that product for your business needs. First of all, we'll be looking at the business needs, growing business needs, which could map to Hazelcast, and we are going to address how Hazelcast is offering solution for a business problem. So the perspective is completely first putting forward the problems which we have in IT, which matches into the products offered by Hazelcast. So before we get into product, it's always good for us to understand what exactly the problems we are facing, and that could be resolved by Hazelcast. So in this 4 hours, before I go ahead, I want to make it very clear. The quick agenda which we are making out here is Hazelcast comes out with a couple of products or tools which we can name. So we'll be introducing a couple of products which is offered by Hazelcast, and we'll be reasoning why the product is in place and why it has captured the market. Of course, if we are discussing about it, it should be popular. So we would be discussing why it is popular and what major products are given by Hazelcast. And each product has some set of functionalities which is offered. So within the limited stipulated time, not only just discussing about the functionalities, we'll also be practically addressing it through the language called Java. So there is going to be hands-on demonstration for most of the things which we are discussing. So we'll not be making a full-fledged example like deploying all the layers, deploying database, connecting it. We are trying to simplify as simple as possible to just to give you the core essence of the product. So let's follow this. So this training is all about Hazelcast. So as I told, the initial thing which we need to understand is the products offered by Hazelcast. If you officially get into Hazelcast official website, you will be finding 3 different things there. Hazelcast IMDG, in-memory data grid, Hazelcast Jet, and as well as Hazelcast Cloud. So first of all, we need to sort out what is this IMDG is and what is cloud is, and finally we could go ahead with Jet. So first of all, what exactly this all actually crucially plays on single area. So the quest that should arise in our mind is what exactly Hazelcast is. Is it a database or is it something else? The answer for this is Hazelcast. Of course, is a database, but it is beyond that. So its capabilities are beyond a database. It is something else also. So we need to understand what that something else is. So the reason why Hazelcast is so popular in the market, why it captured the market first of all is this products Jet as well as Hazelcast Cloud offering and all came recently. So the initial popularity they gained. In fact, today we are speaking about Hazelcast because the prime reason is its popular product called as Hazelcast IMDG. And the question which I put forward here is what exactly Hazelcast is. Is it, I mean, all the products usually address only the same thing. So their core area is it only around database or is it something else? So even this product is IMDG is not addressing the database solution alone. It is also addressing something else. So what I'll do is, first of all, I'll put forward what IMDG is. Before I go ahead with IMDG, I told you that first of all, if you want to understand a product, you need to understand what kind of problems that exist in the market and what problems this particular solution or this particular product is addressing. So before we go and talk about other things which Hazelcast addresses, first of all, primary thing is, even you must be knowing it, it is a database solution. So what kind of database is it, first of all? Again, that question has to be answered. Is it an RDBMS solution? The answer is no. Is it a NoSQL solution? The answer is yes. And in NoSQL solutions, there are various things which you need to understand. Is it something which is offering a document-based solution for storing catalog data, or is it providing any kind of fast access systems like column-based databases, or is it a key value pair database? So when you take a NoSQL system, obviously it will not be following most of the practices which are followed by RDBMS. So for example, RDBMS follows ACID. NoSQL databases won't follow ACID properties. So the categories of NoSQL databases, mostly they fall under the category of document type, column based, and key value. Under what category this Hazelcast falls is, it falls under the category of key value pair. It's not a document based database, or it's not a column based database. It is a key value database. Also, you need to understand, if you take any database, it will have storage. First of all, there are certain databases which will not have any storage. They will be running only in the memory. So as far as storage is concerned, certain databases will have storage. In fact, most databases will have storage, that is secondary storage. On disk, the data will be stored. Some databases, they will not be storing data in the secondary storage at all. Throughout, it will be storing the data only in the memory. So to address Hazelcast, what kind of database it is? Is it a database which is having storage, or is it a database which is having only in-memory storage? So the answer for that is, it is not having any physical storage. It will have only in-memory storage. So as I told, the three primary products, before I go for the next slide and explain the things better, we have to understand, in this discussion, we are going to look at various Hazelcast products like Jet, Cloud, and IMDG. Initially, we are going to start our discussion with IMDG, which means in-memory data grid. And I told Hazelcast is not about only providing database solution. It provides much more beyond. And we haven't even talked about what is that things which are much more beyond. But I told that Hazelcast is a database. So let us start with that point. So in that, obviously, the things which should come to our mind is, if you are learning a database, we need to first understand whether it is an usual RDBMS system where you create tables, where you use primary keys, select statements. Is it that kind of a database? Certainly not. It is not an RDBMS system, and it is not going to follow any of the ACID properties. I told it falls under the category of NoSQL systems, that is, which addresses problem beyond ACID properties. So as I told, there are various categories of NoSQL databases like document based, column based, key value pair. And to elaborate on this, how the data is stored in the database. In RDBMS system, it is always table, whereas in a NoSQL system, it might be document, or it might be a column family, or it might be just a key and value. So in what way Hazelcast stores the data is, it stores the data in key value, and stores is the exact word which we are using. Where it stores, does it store on storage, or is it storing information only on memory? So it is in memory storage. It is not storing information on the storage devices. It is storing only on the memory. That's why we call the product as Hazelcast in memory. What exactly it is? Data grid. So data where it is going to be in memory, and why I'm using the word called grid is it's not a single server which is going to be running and storing the data in the memory. It is going to be a collection of servers or nodes which will be holding the data, and they'll be collaboratively working together as one single unit. So the exchange of information happens between them, replication of information happens between them. So you must be knowing in real time, if a collection of systems working together for one single purpose, by exchanging information among them, by replicating information among them without having a single point of failure, then such kind of system usually we prevalently call it as a cluster, isn't it? So here Hazelcast addresses the problem by providing an in-memory database in the form of a grid. That is, it allows us to create a grid of nodes. That's why the product is called as Hazelcast in-memory data grid. So as I told, the first and foremost thing which we are going to discuss about is the first product called as Hazelcast in-memory data grid. And I told that it is not only about database, it also much more beyond that. This is what that much more beyond is. We'll talk about what other functionalities which we can deal with this Hazelcast IMDG. But the prime thing is it is an in-memory database, and what I told is it works in the form of cluster, and second, it stores information in the form of key value pair, and most importantly, third, it does not support ACID properties, all 4 ACID properties, because it falls under the category of NoSQL systems. So that is what we have derived so far, and we need to up next we are going to understand in deep how is the architecture, how it behaves and all. But as of now, all we have understood is it's a database, right? Second, it stores information in the form of key value, and generally Hazelcast deployments will never be one server or a client server architecture. It's always going to be distributed in nature. That's why primarily it is so popular. Hence they named even the product as in-memory data grid. Right. So before we deep dive into this IMDG, how it works and all, that is going to be up next. But before we move into it, I told that anyway you have solution in your hand, but first of all you need to know what problem I do have to match my business needs. Without knowing the problem, going for a solution will never be a solution. So we have to understand what kind of real-time problems do we have, and how it is addressable by using Hazelcast IMDG. And first and foremost important thing is, before I address the various kinds of problems one by one, anyway I'm going to discuss the problem and the solution offered by Hazelcast. First of all, I just want to tell you, I told that Hazelcast can do things much beyond just being a database. What that is, it offers caching solution. So first of all, we need to know what is caching. I'll go ahead and explain caching, but initially I want to set up the agenda here. The point is Hazelcast IMDG offers caching solution, as well as we'll discuss what is caching, of course. It also works as a messaging system. So there are a lot of in-memory databases in the market. You might have heard about Redis, Memcache, It's a question mark that whether all of them go much beyond an in-memory database, but Hazelcast performs a lot more. It not only works as a in-memory storage, it also works as a messaging system. So again, it is important for us to understand what a messaging system is. So primarily, I'm just telling it is not only about providing in-memory storage, it also provides caching in a way, and it provides a messaging system, as well as it also works as a streaming system. And in fact, the product which represents streaming system is not Hazelcast IMDG. Hazelcast IMDG is part of it, but we need to collaborate Hazelcast IMDG with another product called as Hazelcast Jet. So within this workshop itself, you're going to understand caching, messaging, as well as streaming. So the answer has come. So what kind of problems do you address by using Hazelcast? Is primarily first, if you need in-memory storage, you can go for Hazelcast. But when do you need in-memory storage? If you want to cache your application or database data, obviously we need in-memory storage. So the primary solution or the primary problem is you may want to make your application work so fast. So if you fetch the data every time from database, it's obviously going to be slow. So we need to build a cache. So we elaborate that. We'll go deep into that. As of now, I'm just telling you the problems and the solution offered by Hazelcast. So you might be looking for cache solution. Hazelcast has a solution for that. And second thing, you might be looking for a messaging system. What exactly is messaging system? I haven't told that. But if you are looking for a appropriate messaging system that too works on a distributed environment, Hazelcast is again a perfect solution. Third, if you want to stream information or if you want to do stream processing, and if you remember, or if you are following the IT environment closely, for the past few years, all these three things are most happening things in the industry. Caching, very, very essential part of our industry, because the point is we need high throughput as well as we need low latency. We talk about what is low latency and high throughput. So everybody wants information to be processed so fast, and we want response so fast. So unless you cache information, that is not going to happen. So products which address caching are so popular in the industry. And similarly, messaging. Messaging is, as the picture itself is depicting, an application might want to communicate with another application. Maybe they might have been written in a different technology. We need a centralized point where I can publish some information where others can subscribe to it and get notified. So that idea is nothing but a messaging system. We'll talk deep about it. But in modern day market, certainly we have a lot of requirements around messaging. And the third thing is data streaming. That is, if you have a distributed environment with continuous data which is being produced, and you may want to read that information, process it, and maybe you want to store it in another database setup, which might be further used for analytics or any other purpose. So loading information from one place, and you might have heard about ETL systems, right? Extract, transform, load. So exactly that operation is performed by a streaming system. So all three things has become an essential part of IT in current market, that too on a distributed environment. So these three essential solutions, all three essential solutions which are very popular in the market, is offered by Hazelcast. So we should not just confine it just to be a in-memory database. It's not just that. It plays its part in three important areas. It works on caching, it works on providing a messaging system, also it works on providing a data streaming system. So as and when I go step by step, first I'll be sorting out what caching is and how we resolve the problem by using Hazelcast, which is a hands-on demo. Then I'll talk about messaging system. Then I'll give you a simple demonstration on how it works as a messaging system. Also, I'll give you a demonstration on streaming system. So this is how this session is going to proceed. Very clear. Step 1, talk about caching and understanding how Hazelcast is offering solution for it. Step 2, messaging system, what it is and what other products are there, and how important is it in real time, and how Hazelcast is offering solution for it. Third, what is a streaming system, how important it is, and how Hazelcast is offering solution for that. So that's it. So we understood. We're going up ahead with IMDG first. And when it comes to IMDG, it offers in-memory database solution. And apart from that, this in-memory data grid can be used for caching, and it also can work like a messaging system, and we can also use it for data streaming. So that's what I have put forward so far. And so the first problem I'm going to talk about is caching systems. I told, right? So we'll be going by 3 steps. First, we'll see what is caching. Then we'll talk about messaging. Then we'll talk about streaming. So let us first talk about caching as a problem. And it's a known fact that Hazelcast, end of the day, it's a DB, and it falls under the category of NoSQL system. And why a NoSQL system should be in places? Here in SQL, the information processing is always tabular in nature. So always it is tabular in nature, and there exists relationships and joins. So obviously it needs to tick to the properties called atomicity, consistency, isolation, and durability. So if these 4 processes are happening, you have to understand wherever there is consistency, obviously what happens is there might be some sort of delay, because if you want to provide something consistent, you cannot make the data available always, right? Because you need to lock it. And for example, particularly in a distributed environment or a client server environment, if one row is already accessed by a user, same time another user cannot be allowed for a write operation, because you need consistency of it. So this guy obviously needs to wait for the transaction to be performed. So obviously his request is not addressed. If something is not addressed, obviously it is considered to be a delay, right? So there is a latency in getting response, right? So obviously if you're sticking to ACID properties, performance wise, you need to have some compromises in terms of the overall throughput. But there are some real-time cases where you might not be expecting consistency always. What you might be looking is basic availability. Regardless of anything, I want my data to be available for operation at any point of time. And I'm fine with what? Eventual consistency. So if we want to talk about the theory of NoSQL itself, we can almost do the whole workshop time for NoSQL. I'm not going to get that deep into NoSQL theory, but I just want to simplify as simple as possible. So what I want to put forward is, in a SQL system, since it sticks to ACID properties, obviously there is a problem with performance. That is, it will have high latency. That is, latency means the response time. Because of its consistency nature, the response time might be large, and always availability will not be there, because some records might be locked when some user is working with it. But that might not be the case in real-time processing always. For example, if you are viewing a product catalog and all, or if you are working with some social media sites, The consistency of the data is not important there. Whether I'm able to interact with the system always, whether I'm connected always, whether my messages are getting communicated with others, even if the order is missing, no problem. Suppose if I'm posting two photos, photo if it is distributed in a different order also, in that context I might not be worrying much about it. So you might not be looking at consistency, yet you want it to be consistent eventually. That is not immediately, eventually the data can get consistent. In what context we are speaking is in a distributed environment. Suppose if a user writes data into this system, it has to be replicated to all the systems in the cluster. But without immediately replicating it, you can eventually replicate it so that the data can be consistent in all the places. So before it replicates, if a other user makes request to this system, still it will provide it. Whereas if it is a consistent system, unless it is replicated everywhere, it will not be giving data to the other person. That is what we call a consistent distributed system. But if it is eventual consistent, even though the data which is written here is not replicated here, still the data will be made available to this guy. That means he's getting a older data, but eventually the data will be, for example, in few milliseconds or few seconds, you'll be getting the newer data. So you are okay with eventual consistency, but if you want basic availability, generally you'll go for NoSQL system. As I told, there are various use cases to get to a NoSQL system. So if you want to build a product catalog where you don't have a proper structure for your data, you'll go for document based databases. And in a table, if there are some 50 to 60 columns, and if you are performing a query on a particular column, say city, every time it has to go to an entire row. In that entire row, it has to go to city and then search it. So row wise searching will be a problem always if you are storing information in rows, that too tables with wide columns, that is too many columns. So such kind of wide column tables can be stored in a column family database where the data will be stored in the form of columns, that is city, and I'll store only the city table values, and I'll be associating with the keys. For example, employee number 1, this is the city, employee number 2, this is the city. So if you search for city, you will go only search the city, you're not searching the entire row, and you get to know that it belongs to employee number 1. So you can make the search operation so fast. So if you are storing the information in the form of columns, that is a column family database. And suppose if you want to store information only in the form of a key and a value, for example, username X, password is something, username Y, password is something, only key value if you want to store, that is what we call a key value store. Apart from that, if you want to store information in the form of a graph, even such kind of databases also there, graph data structure, even that kind of databases are also there. So these are the various ways solutions are offered, and as I just put forward already I repeated it 4 or 5 times. Our case is a key store, and our case is it's a NoSQL system, and it is basically available. It is okay with eventual consistency, but also if you want to have a consistency, even that can be configured. So it is very flexible. It also supports eventual consistency. Also, it supports consistency as well. You can configure it. When I explain about the architecture, you'll get to know. So that's what I told. Asset properties, RDBMS uses it. Atomicity, consistency, isolation, and durability is the 4 features. Whereas base is not an universally accepted theory, but it is a common term which is spoken. That is systems which look for basic availability, soft state. That is immediately you are not storing your state of data in all your systems. You're just maintaining a soft state. Eventually you'll replicate it everywhere. That is what they call soft state, and it is eventually consistent. And not to lose the knot, The order in which we are going is, initially we are trying to look at how IMDG is offering a solution to be a great cache system. So to explain that, the first thing I told is Hazelcast is an in-memory data grid. The way we store information is key value. That is sorted out, right? That is what we have discussed. The second thing is we need to understand about architecture right now. Then we'll talk about caching and how the solution is offered. So in industry, and this is more of general discussion which we've been having so far, but each and everything which we discuss is commonly applicable for many things. So there are two important terminologies which everyone should know, and you would be knowing it already. In case not, please observe these two terminologies, very important. Typically, when you are going for a client server architecture, and concentrating on this is very important so that you can understand the product so easily. In a client server architecture, you will have built up a server which might be communicated with or communicated by many clients. So if the number of clients always that are communicating with the server is always high, the problem is the load on the server will be too much. So obviously, based on various metrics, you might decide to scale it. That is, increase the capacity of it. So when we talk about capacity, always two kinds of capacity which you might be looking at. Compute capacity, that is increasing the processing capacity, memory and storage. As the picture itself is telling you, compute comes with RAM and CPU. Storage is secondary hard disk. So compute will be always two things together, and storage is for secondary storage. So you might want to go for more storage and more RAM and CPU. So what you'll do is you'll be increasing that RAM capacity as well as you'll be enhancing it with the better processors in the same system. So if you are doing it, it is called as vertical scaling. In other words, we call it as scale up. But it is not a viable solution because it is a single point of failure. That is, if the server itself fails, all these clients is going to be getting affected. And with time, if the load further goes up, you have to always work on the same mission and you have to keep increasing the same server again and again. And since the current market is about distributed processing, how far it is viable is a question mark. Generally, the viability of this system depends upon the number of clients and your current business needs. Suppose if you are looking for a distributed processing, right? This is very important because this is what we are concentrating. So I have a commodity system, that is a system with a minimal processor, some RAM and some storage. What I can do is through network, I can connect it with another system, and through network I connect with another system. Suppose assume that this is 16 GB and 16 GB. I'm talking only about the memory, 16 GB. So obviously what happens is I got 48 GB of memory for processing. All right. And let us assume it has some 512 GB storage. This has 512 GB storage. This has 512 GB storage. 1536 GB is available there. So if you want to enhance it further, you don't need to think too much. Just enhance one more system with the same capacity. So obviously what happens is 48 becomes 64 and it will become 2024. Sorry, 2048, 2048. I mean the storage. So you can keep on increasing the capacity by adding a commodity hardware and interconnecting the system, and all of these systems will work for the same purpose, maybe offering a database service or offering an application service, whatever. So this kind of environment is what we call as distributed environment. And this kind of scaling is technically called as scale out. and the kind of scaling is called as horizontal scaling. So why I'm stressing this point right now? In memory, I already sorted out in memory the way information is stored is key value pair. We talked enough about it. Data, that is what key value. Grid, that is the system in which you are deploying Hazelcast is going to be a grid of systems. That is, it is going to be a cluster. That means it is not client server architecture. It is going to be a grid architecture, that is a cluster architecture, that is a distributed set of systems. So what obviously the conclusive thing that need to come to your mind is it follows what? Scaling out. So if your compute capacity needs to increase, all you need to do is increase one more node. If your processing capacity, that is what we call computing capacity. And second, and obviously it does not have storage because it's an in-memory database. So only it's about RAM as well as processing. Secondary storage, we don't bother. All right. So the kind of scaling which we follow in in-memory data grid is horizontal scaling. You'll see that in the practical example which we are going to do just within a couple of minutes. You'll see how horizontal scaling is happening within a cluster. But before we go there, I just want to keep it very clear that the information stored is key value, and the second thing is the scaling that is happening out is scale out, that is horizontal scaling, because the processing is distributed processing. So any system when you're building, first of all, these are the things that needs to understand in any product selection nowadays. Everywhere we talk about whether it is scale up or scale out, that is whether it is vertical scaling or horizontal scaling. Then we'll talk about throughput, what is latency level. All these are addressable things when it comes to choosing a product. So let us go and understand latency and throughput. Two important terminologies, one which everyone should know. Very, very important terminologies. Throughput, because every product selection and every deployment is measured with the help of this latency as well as throughput. So what is latency is, as it is mentioned here, time needed for a packet transfer, or in other words, what you can understand is, here it is represented in terms of network, but if you have deployed a database or if you have deployed an application, in terms of application, if you make a request to the application, obviously the application would respond, right? To whom? The requester. This guy is using a PC and making a request. The time taken for responding to the request is what we call latency. So obviously it has to be low. If it is very high, the system is not performing well. So that is one aspect, but maybe the amount of information processed might be very less. Hence you might be getting the response so fast. That is fine. But if you increase the load of information that is to be processed, suppose if you want giving a request for processing, say 1,000,000 records. In that case, if you are getting for say you gave a request for 1,000 records, you got some latency, and if you give a request for 1,000,000 records, if the latency falls, that is if it becomes high latency, in that case there is a problem. For every case it is not working in the same range. That is, another measure needs to be taken into consideration, that is throughput. That is the quantity of data that can be sent and received within a unit of time, or in other words, the quantity of information that is processed by the application. If you're talking about application term, the amount of information processed by the application is what we call throughput. In case of databases, if you're talking about it, the amount of information processed by the database in a given point of time is what we call throughput. So always remember, you need to build a system, any distributed system, which has high throughput. So if you need to have high throughput, we need to have good compute capacity. That is, you need to have good CPU with you as well as good amount of memory with you. And for example, even if you're looking for storage, in the context of Hazelcast, it is not required. but usually you need to have good computing capacity and good storage capacity to offer high throughput. So obviously, if you have that, you can establish or you can achieve low latency. So a perfect distributed system always is something which has low latency and high throughput. In case if any of them, or obviously since they are interconnected, what should you take care is you should look at scaling out, that is horizontal scaling needs to be taken care, because we are talking about a distributed system here. So the solution for getting this is horizontal scaling in case if the throughput or latency falls, right? But the point is always one need to remember when you are thinking about a system, always remember whether the system is providing latency and throughput. And you also need to understand the product which we are talking about, Hazelcast IMDG. As I told, it is horizontal scaling, and it always aims at providing low latency and high throughput. And you also need to, it's not only about throughput, is one more factor is important here. It's not always about compute capacity. You might have a very good processor, you might have a very good amount of memory, yet the throughput might be less, because if you are sticking to properties like ACID, if you're looking for consistency, even though the processor is ready to process, since you're looking at the rules, you're not allowing a particular set of records to be processed because you have logged it. In that case also throughput impacts. It's not always about hardware, it is also about the principles which you infuse that need to be kept in mind. So if you are looking for better throughput, you have to think twice whether you need consistency or whether you could compromise consistency. Many databases you could compromise consistency because you might not be looking for consistency. For example, you may want to just retrieve some data in any order. You might not be looking at consistency of the data. In many cases, for example, logs. In log, anyway time is going to be there. If you are reading 5 different files, you can retrieve it quite, you want to retrieve it fast. You don't need any consistency in retrieval of the information. So if you are looking at some data where you are obviously not looking at consistency of the data, you can compromise consistency and you can move to a NoSQL system. So that is about latency and throughput. Now let us talk about our actual point. I already told, let us not lose the thread. Cache is the first aspect which you are discussing. So before we move to cache, since we need to understand the architecture, I just told what are the things which you need to focus. First, data structure, we understood. Then about scaling, we understood. Then about latency and throughput, we understood what factors influence that. Right? So data structure, key value, scaling, horizontal, and I told that CP and AP both are supported by Hazelcast. CP means consistency, priority will be given for consistency, and partition tolerance. There is a theorem called as cap theorem. I haven't discussed deep about it, but I'll tell you one thing. Consistency, availability, partition tolerance. That is, even one of the partition is failing, I mean even if one of the node is failing, still the system works because there is a replication of data, because you do have a distributed environment. So if you are looking for a distributed environment, all three properties are never possible. If you have a partition, surely either you opt for consistency or you opt for availability. I told you, if you're looking for consistency, you need to lock. So obviously it might not be available. If you're looking for availability, don't go for locking. So don't look for consistency. So predominantly Hazelcast is AP in nature, that is availability plus partition tolerance. But if you want to make it work for consistency also, you can configure it. That is what I'm trying to say. So even cap theorem brought into picture. So we also understood about, and what you are looking for, whether you are looking for consistency or availability, influences a lot on latency and throughput. So since we have understood all the essential things which you need to consider, the next obvious thing is its prime functionality called as providing a cache layer, right? So now let us talk about where Hazelcast comes into picture. And now let me just show you. This picture depicts a real-time application deployment, full stack deployment from this corner to user corner. So as the picture is depicting, the user might be using a device. In that device, particularly understand, you might be using a browser, right? Because this discussion is all about this word called caching. You might know how important it is. So through browser, say if you are making a request for HTTP, through the internet, you might be using some load balancer or a server here. You can even take it a web server in which you might have deployed application might have been deployed on the database. So my point is, suppose you made a request for page index.html. That index.html is actually part of the application. So very first request, the server will, the load balancer will get the information, then it will pass it through the internet through the client. And mostly if you have observed in your browsers, when you make a request for first time, it will be very slower. Second time, third time and all, if you make the same request, same web page is loaded, means obviously it will be faster. Reason is browser itself is maintaining cache of web pages. Second time, third time and all, if you are looking for a same page, it won't make a request again. It will take it from the cache memory itself to offer better experience for the user, because even end of the day, browser is also manufactured by a company. They also have the competition among other players. So they want to give a better performance. So the data which is retrieved from the server, they will keep it in the browser itself. Second time, if a request comes, again they won't read it, because to read information from the network always it takes time, and it depends upon the bandwidth. So browser maintains a cache in itself. And second time, suppose this user has given a request, suppose altogether a new computer comes. If this guy makes a request here, even this load balancer or a server, whatever you deployed, they also have competitors. They also want to provide a better offering, right? So already a user has made a request for index.html. Second user is coming and making a request. He won't go to this application and he won't search this index.html again. This guy will also be maintaining a cache for himself, this software, and it will be maintaining a web cache. So second request or subsequent request for the same resource, from here, from the cache memory itself, it will be served for the other people. So this is cache maintained at the application server level, and first level is at the browser level. And for example, let us assume you are calling a URL call /people. That means people data has to be read from the database, and it has to be processed by the application, and it has to be sent to the place. So every time you make a request to the application, here you are reading the information. So as long as no write operation has happened in the application, there is no point in reading the data again and again. So what application will do is, it will maintain a cache layer, that is the data read from the database will be stored in the cache of the application, which we call application cache. Subsequent, even the application also wants to perform better. Prime reason is latency needs to be reduced, because if I go and talk with the database, it is going to increase the processing time. High throughput is needed, that is processing amount of information should be very faster and higher. So I don't need to process it again and again. So I'll maintain a cache in the application level, which we call application cache, and I'll store this information in the application cache and I'll provide it to the user. So from this, what we have understood is, for this guy called end user, to satisfy this particular guy, look at how many people are or how many softwares are working by consistently maintaining something called as cache. Look at how important it is to offer, because now everything is interlinked, isn't it? Whatever we are talking, I told you about latency as well as throughput. If you want to achieve it, I told you the problem, but the solution is at each level there must be something called as caching, because every time you don't need to process the information. Second time, third time, if you are looking for the same information, there is no point in wasting the time on processing, wasting the time on reading and doing stuff in the processor. Since we have the data already in place, you can provide the same processed information again to the user so that it enhances the performance a lot. So every single deployment in the whole stack, they'll be having their own way mechanism to cache the information. Say a browser maintains web page cache, and even a web server maintains cache of the pages, whereas an application maintains cache of the data which is fetched from the database. Even database also maintains its own database cache. Same query which is performed again and again, it won't run the query again and again. If a request is coming for the same query, it will look for the cache whether the query is already processed or not. If it is already processed and if it is maintaining the results, it will give the same result. So there is no system in the IT infrastructure which is not maintaining cache. Everywhere there is cache involved in the system. So our Hazelcast IMDG, where does it come into picture? Will it come this area? No. Will it come this area? No. Will it come within the database? No. When you are building application, this application may need a cache layer for what? Low latency and high throughput. So to provide that, we go for a Hazelcast in-memory data grid to offer a caching solution. So I think I have put forward the things in a logical pattern. And to conclude this discussion, you need to understand, to provide application with a cache, what we are going up with is something called as in-memory data grid, which is offered by Hazelcast. How it is deployed, what is part of in-memory data grid, that and all we talk. We are just talking in general terms. So we understood it offers three different kinds of things: caching, messaging, and it is also used for streaming. I told you remaining things we'll talk about. The first thing I wanted to talk about is it offers caching solution. So why caching is needed? For that also I put forward the information. Throughput, latency is what we are concentrating. What factors influence that? The type of data which you are processing, as well as in cap what you are giving priority, whether you're giving priority for consistency or availability. These factors play a crucial role. Apart from that, to enhance the performance, what we can do is we can go for caching. So that caching can be achieved with the help of Hazelcast IMDG. So since it is an in-memory data grid, to enhance the performance, you can horizontally scale it. So as far as scaling is concerned, it is horizontal scaling. So this is the overall big picture of Hazelcast. I hope you have understood where Hazelcast comes into picture, where is particularly IMDG is coming into picture, and we call it a database. In what way it is a database, what kind of information it is going to store. So certainly by now you should have understood it's not a primary database. It actually gets information from a primary database, maybe an RDBMS system. It stores information in the memory for quick providing to the consumers of the information. This is all about understanding the problem that is called the importance of caching, and how solution is offered by Hazelcast by using Hazelcast IMDG. So we'll talk about how this in-memory data grid solution offers the solution, but as of now, we have understood what is Hazelcast. I told not in deep, we just understood Hazelcast as a company. It offers three important products as of now. In that, IMDG is very, very important. And we also understood the various kinds of databases, and we just understood what is in-memory data grid. And we also understood about the importance of caching and how this caching system is provided by Hazelcast by using a component called as Hazelcast in-memory data grid. So yeah. So as far as this applications is concerned, it needs a cache, and we are going to go ahead with a data grid by Hazelcast. So as I've been telling, if this guys or here the depiction is application level caching, but any form of caching is, if there is no caching from the source, always every time it has to read. But if it is not, if it is cached, second time onwards, you can read the information from caching. So as I told, at each level caching can be there. Within the database itself, there is caching. In application, there is caching. And in server, that is caching. Even in browser, there is caching. So at each level, there is caching being maintained. The case which we are discussing for our need is application caching. So this is exactly what we'll have a couple of applications, even one application that is our wish. It's all about how we plan our deployment. So data base. So we'll be constantly reading the information and we store it in our in-memory. And similarly, there are cases where you can write data directly to the database. We can use only read through. We might not be using the database for writing the in-memory data grid for writing the information. There are some strategies where you can directly write the information into database using it only for reading. That is one strategy. Or you can write your information to the memory grid. It will write in turn to the database. Both the strategies are followed, which we'll discuss deeper. But as of now, this is what the physical infrastructure is. Application, database, usual way of communication is directly from here to here you might be communicating. The point is every request made by the user, every time you need to communicate with the database and get the information. So obviously it impacts your throughput as well as latency. For that, for offering a better solution for the user, you can go ahead with in-memory data grid. So this is just a block diagram, but technically in deeper, we'll go ahead and understand. So this is a typical Hazelcast cluster. See, remember one thing, when we talk about cluster, we need to understand few important terms. Machine is very important. It is physical or even it can be a virtual machine. In a way, anything which is uniquely identifiable by IP is what I call machine here. Even it can be a container also. That's up to us. In a physical machine or a virtual machine, what you can do is you can run a node. In case of Hazelcast, a node is called as a member. A running Hazelcast server is what we call a member or node. So it's a very, very simple process. If you run Hazelcast, it is what we call member. So as the picture depicts, within a machine, in some systems, sometimes when you build a cluster, in one machine, you might be able to run only one server. it depends upon the software. Whereas in case of Hazelcast, within a mission, you can run as many members as you want. But the problem is if the mission fails, all the members will fail. And you have to understand each member will run on a particular port number, say 5701, 5702, like that. So multiple missions can be coordinated together. Maybe they might be connected with a virtual network or something. So we form a cluster by forming multiple missions. More than the mission, the important thing is members. So a member is always associated by IP port number. Combination of these two things identify a member. So the terms is a cluster is nothing but a collection of system where each system will be having a couple of Hazelcast member running, and each member is usually identified with the help of its IP address followed by the port number. So multiple port numbers can be, within a system there can be multiple port numbers. On each port numbers, a particular Hazelcast member will be running. As I told, 5701 is the usual port number, 5702, and so on. So here the actual point is when you have a cluster in place, and as I told, the environment itself is distributed. Even the application and deployment would have been distributed in nature. So in a distributed application deployment, the application could have been written in Java or .NET or Node.js. So it is not a technology which is specific to Java, but mostly it's known for working with Java because even Hazelcast itself is written in Java, most aspects. But still, all major popular languages is capable of interacting with a Hazelcast cluster. As I told, this is going to work as a cache layer which gets information not only from RDBMS, it is capable of storing information in any format, from any data source. And you have to understand the way the information is stored here is key value, and in Java, because I told you that Java is the language involved. So in Java, the data structure which holds information in the form of key value pair is a collection called as map. So these guys maintain map as the collections to store key value information. This is the top level architecture of Hazelcast cluster. The terms which you need to remember is mission, member, and collaboratively working together as a grid or cluster. So one more depiction of the same stuff. So if you are deploying a this is, to be precise, a monolithic deployment. You must be knowing the difference between monolithic and microservice architecture. So monolithic is deploying your application in one area, one application server. Your entire code might have been deployed as a single point. This is a client server architecture, whereas this client server architecture is depending upon this cluster to deal with cache needs. So this depicts a monolithical deployment where the cluster is outside the application layer. It is not tightly integrated with the application layer. A cluster is separately working where each member is called as a worker node. It has in-memory data layer and it has a compute layer as well. So it is fetching or writing information onto the data source, and a collection of nodes are working together to provide data. So as of now, for most of you who are listening, it only be a conceptually, you can only imagine things when I am explaining, but please wait. Within 10-15 minutes when I go for the hands-on demo, every single word which I am uttering here will make sense. But if we lose here, probably there to correlate things, it might be a small problem, but I'm just putting it in simple terms here. Same simple implementation is also going to be explained in the hands-on also. So in this, what I'm trying to say is the cluster is nothing but collection of members which are working, which is maintaining a data layer which would be consumed by your application layer. Here the cluster is entirely separate from the application. That is what I'm trying to put forward here. And this is a typical monolithic deployment, not a microservice deployment. Monolithic means a typical server, application server, and client. In application server, you might have kept the code, maybe like WebLogic or WebSphere or Tomcat, such kind of stuff. I'll come to the architecture. I'll talk about this architecture. Before I talk about this architecture, this example demonstrates, this architecture demonstrates a microservice deployment. That is, look at this, compare the previous picture with this picture. This picture is in a microservice architecture, each microservice might be working for a dedicated purpose. For example, it might be dealing with employee data. This might be dealing with payslip. This might be dealing with attendance. So 3 different microservices are there. So instead of going for a cluster which is outside the application layer, each microservice can have an embedded Hazelcast server. Within the application itself, there is Hazelcast server. About scaling, is there any limitation there? It depends. That is, if you are deploying a cluster outside, you have to monitor a lot of things based on the number of microservices or based on the application which you are using. You can go for scaling option, you can enhance it. Whereas in this case, every unit that is working here, there are 3 deployments. Maybe you might be even replicating it. So for each unit, along with the microservice, you are embedding Hazelcast server also. One microservice running means along with it, one Hazelcast node is also running. So here there are 3 microservices, 3 nodes are running. So these 3 things together will form a cluster. We call it embedded cluster, because within the Java program itself, the cluster is running. Whereas in previous example, which I told, the monolithic deployment, the cluster is outside. This deployment is within the running program itself, the cluster is there. This is very, very effective. Suppose this fails, no problem. Still, you have 2 members in the cluster, and wherever the microservice is running, an associated Hazelcast member will be there, and the data will be usually replicated. The data which is part of this can be here, which is part of this can also be here. So when we get into the hands-on, you'll be definitely knowing it. No need to worry about it. And to manage and to look number of nodes running and what data is present in them, there is a component offered by Hazelcast called as Hazelcast Management Center. So I'm also going to demonstrate this Hazelcast Management Center within a while. So look at this picture. Within a while, exactly this implementation will be seen by you. So 2 things. First thing I have explained is about this one, where the cluster is outside the application layer, whereas in this, the cluster is built as part of your deployment itself. Every microservice itself is carrying the Hazelcast instance within it. So that is what this picture depicts. So if you want to deploy Hazelcast IMDG cluster, there are 2 deployment options. One is client server mode, that is build a cluster of Hazelcast IMDG servers, that is member 1, member 2, member 3. They are running independently, right? They might be in the same machine or different machines, but end of the day they are clusters, right? And your applications will not have an embedded Hazelcast member in it. They'll work like a client and they can talk with the cluster and they can fetch the information. So this is one strategy. This strategy is called as client server mode, and exactly this picture depicts it. This is what this one is. Client server mode is. The other mode is embedded mode. So your application, you'll have a Java API to directly invoke IMDG. So this three things will be tightly packed. So within the application layer itself, IMDG server will be invoked, and as long as this Java program is running, the node will also be running. If you close this program, node will be shut down, and set of your application will form a cluster. So within the application itself, the cluster is getting formed. So this is very, very good for microservice architecture, which I have just told, right? So the exact picture which is depicting that is this kind of deployment. So it depends. So when you're going for microservice deployment, the best way of deploying your cluster is embedded mode. When you're going for generic, I mean, an application might have written in Java, and another application you might have written in PHP. Both the applications might need same cache layer. In that case, if there is two different technologies which might be looking at same cache layer, such kind of scenarios you can go for a client server mode. So you have two wide different options. So look at this. This is very, very important. These are the choices of deploying a Hazelcast cluster, which I'll be explaining practically. So before we go for the practical stuff, the last and final stuff which I want to explain as part of the second set of discussion is, and still remember, don't lose the chain. All we are doing is about caching, right? So now let us understand the architecture of Hazelcast in-memory data grid. That is, it gives architecture of one member. If you deploy one member, what exactly will be there is, so the deployment can happen on a Java virtual machine, because you have to understand, end of the day, Hazelcast is a Java program, to be precise. So it works on a virtual machine. Virtual machine works on the operating system, and operating system can be on any platform, right? Core platform. So the key thing in your engine is, and since it is an in-memory database, look at this. They are not talking about disks or anything. They are just talking about heap store there, because your Hazelcast is a in-memory data grid. It is not something related to physical storage. So when they talk about storage, there is no talk about disk or any files, nothing. Heap store, because since it is a Java process, you know, Java programs run on JVM, and the objects will be there in the heap memory. So the store is what they call heap store, right? So when the node is created, it will have its own networking configurations associated with it, and you have to understand there are various tools which can be used to get information about this node. You might be connecting it to Zookeeper. If you have acquaintance with the area of big data or any cluster environment, if you have worked before, like Hadoop or Cassandra or any cluster based databases, in the world of big data, to know about what servers or what nodes, even if you have learned Kafka before, Zookeeper basically gets the information about nodes. Even Eureka is the same thing. It gets the information about microservices. So there are various such components which is meant for cluster management. So to manage cluster, it has APIs to connect with any of this. So you can pass information to Zookeeper, or you can pass information to Azure. You can pass information to Eureka. So it is collaborative with any kind of a cluster management tool to provide information about the running node, right? And then your engine will have details about the threads which are running as part of the node and other stuff. And very important, I haven't told about this word called partition, which I'll tell you just after finishing it. So remember, I want to tell you about this word called partition. But apart from that, what basically this engine does is to provide information about itself. It has APIs to interact with major cluster management tools, and it has a networking component. Also, it has a thread management engine. And apart from that, I told it is mostly an AP system. So the default priority is for availability. But if you want to configure, you can make it work for consistency also. There is a CP subsystem also part of it. And I told that when you have this engine, on this engine you can store the data on the heap store, but in what form you can store the information is there are various data structures that are supported: set, list, queue, reliable topic, and it also maintains logs, all this stuff. So for messaging, it provides topic and queue. And how internally this data structures are maintained is it makes use of Java util package, as well as it also has internal listener libraries like Tomcat, Jetty, which is part of it, and it maintains a cache layer by using Jcache and Hibernate cache. So with this, using APIs, you can make the application layer write and read information, both the directions. So nothing much too deep dive about it. From my explanation itself, you can understand the takeaway point from this architecture is, I want to make it very clear. A Hazelcast engine or a member, if you run a server, what it is a Java program, nothing beyond that, right? So it's a Java program. So when it is a Java program, obviously it needs to run on JVM. Obviously the data will be on heap store, and obviously it is multi-threaded in nature. So the process which is running, everything will be managed by the node engine. And there is one more thing called as partition management, which I'll tell you. And apart from that, to provide information about itself, it has libraries to connect with any of this cluster management utilities. And how it is going to store information by using various collections. That is as simple as that. Don't think it in a complicated way. It is a very simple Java program which has this components. When I run it, you'll get to know it's just a Java program. You don't need to spend hours together to install it and bring the setup, nothing. It's a matter of minutes, in fact seconds, to form a cluster. All right. So this is about the structure of or architecture of Hazelcast member. So in this second set of discussion, what we have understood is, as far as caching is concerned, we discussed about the deployment options. I told you there are two cases. One is client server. Another one is embedded. And we've seen various Hazelcast components, and we understood what is cluster, what is node, and what are clients, various possibilities. We understood various languages can be clients, and we understood what cluster is. It's nothing but a collection of members. Members will be usually part of a machine, right? So this is what we have seen as far as Hazelcast is concerned. Now it is time for us to understand how to practically up a cluster, right? So in this is what we have seen. So first we have understood the nature of Hazelcast, what it is capable of doing. Then we understood the importance of caching, and now we have understood how to build a IMDG cluster. We have two options. Let us go and explore how it can be achieved. So I have before I go to the demo, I just want to set up the agenda for the demo. Plan is just to tell you about what cluster is and how it behaves and how we create a cluster in terms of Java and how we put data into it. That is what the first hands-on is all about. So before we understand anything, I have set of programs already running. Let me stop it. For you, after the session also you might be trying to work on. So first try to download IMDG Management Center download. I'm just giving you insight where to get this software. Otherwise, it's not a parallel hands-on session which you might be doing. Just I want to give information for you to download how to download the stuff, how I have done it. So if you are not looking, I told you that there are two cases, right? One is client server, another one is embedded. So if you are looking for an embedded option, you don't need to download anything. If you are looking for a client server, so to download the server software, this is how you need to download. So this is a zip file, download it. Then you'll find a bin folder. In that you'll find a server. To start, you can start a node. So that is how you start a Hazelcast server. But I'm going to show you the embedded mode right now. And apart from that, there is a tool called as Hazelcast Management Server. If you remember in the theory discussion, I just told you Management Center will get information about the cluster. So this is a zip file, you need to download it. I already downloaded it. I have that in place. All right. So two softwares, and this software is absolutely not necessary. Which software? The Hazelcast IMDG server is not necessary. If at all you want to run it in embedded mode, I'm going to run it in an embedded mode. So I'm not going to download it and run it. If you want to run it separately, you can use this. Second, to know about your cluster more elaborately and to understand what nodes that are running, you can make use of Hazelcast Management Center, which is meant for cluster management. Okay. This component I already downloaded and it is in place for me. In fact, the management center is actually running for me in the command line. I'll show you. Once we downloaded the management center, this is how it appears. To add a perfect clarity, this is management center, not the IMDG grid. This is just the management center. You have to go to this prompt and you need to run the start.bat command so that a web application will run. Why this web application? This web application will give information only about what? Cluster. This is not about starting the cluster, or this is not about creating a cluster member and all. Just give information about the cluster, right? So I already started it. Look at the another command prompt. I started it. It is running. Logs are being displayed for a very long time. It is running since morning. So let us go to, already there were two nodes running which I just stopped, isn't it? So localhost 8080. So that is the port number. So look at this. For the very first time, you need to say what cluster you are identifying. So I just mentioned in your local system, if you are looking for your local system cluster, just create a dev cluster. So I already pointed out the dev cluster, and you don't need to think too much about it. If you just open for the very first time, there would be an option here which will be displaying dev cluster. If you just click it, it will look for the members which is running in the local system, so that your dev will be enabled. So I'm going to select this development cluster. I'm going to proceed with it. So look at this Hazelcast management center is showing about the cluster details. There is no clients. Earlier there were two members, but right now I have stopped it. and the various data items which might be stored. You might be adding data into maps, you might be having caches, you might be, if you are using it for messaging, you might be having queues, topics. But right now it says an error occurred when trying to connect to the cluster named dev, because there is no cluster running at all. There is no member running at all. So even though the management server is running, it is not able to pick up anything, isn't it? But in a while you'll see it will be showing stuff. So I have a program already. I told I'm going to run it in the embedded mode. I told you, right? So if you are creating a microservice, within the microservice itself, you can embed a member, Hazelcast member, right? That member can have its own storage to store data, as well as other members can share it, right? So let us understand that better. So Hazelcast server, nothing complicated here. All you have done is in your, I believe you must be knowing Maven. If you are in Java background, if you are not into Java background, don't worry about it. I just used a Java library which depicts, which represents Hazelcast. So there is a library called Hazelcast all. I just use that library. And once I use that library, I can be able to create a new Hazelcast instance. A new instance is nothing but new cluster member. So since I'm going to run the program in this physical system, a cluster will be created, right? And I'm not going to put any data, just only one line I'm writing, right? So let me run it. And if you wonder what else is there in the program, there is nothing beyond that. Only in the POM file, that is project object model.xml, I have a Hazelcast library added, and here I have one line of code which just says create instance. Apart from that, we are not doing anything, right? So let me run it, because let us do it in a simplified fashion. See, look at this. On 5701 port number, it is running. As I told, a cluster member will be always identified by the IP address. So this is the local IP of the system, and the member is running on the port number 5701. Currently, there is only one member in the cluster. So cluster is formed, members, only one member is running, right? In which system? This system, right? And remember, a member is just a Java process. And now I go to this immediately, automatic. I didn't do anything. Automatically, what has happened is this Hazelcast Management Center is able to get the member. So this is the IP address of the member, and look at this, based on my system's RAM capacity, the size of the member will be there. So the version of the client, one second. OS total physical memory of the system is this, and committed virtual memory of this. Free physical memory is this. So a member is running, but the management server itself, center itself, is being treated as a client. But as far as the storage data is concerned, there is no data yet in the cluster, right? Now what I do is I add these two lines. Same program, I run it once again. So if you run it once again, it will run as a new copy. So automatically what happens is, whenever you run and if you try to create a new instance, it will try to start from 5701. If 5701 is already occupied, it will go for 5702. So let me run it once again, but this time I'm adding data. I'll explain these 3 lines, but let us see whether the server is getting started or not. So look at that. A new member is added, 5702. 5702 is the member. So automatically new member getting added. And if you could go and look at this cluster right now, maybe in minute or two, you must be, yeah. immediately it changed. Even I didn't refresh. So now what I'm going to do is, and also since in this case we added the data also, right? Look at this, a map is there in the storage. Customers is the name of the map. It has 2 entries. And when you click it, automatically what has happened is the entry is automatically replicated in 2 systems. One entry moved here and another entry moved here. So they are sharing the information among them. And if we stop the server, automatically what happens is the 2 entries will be part of one member itself. That's how the data exchange happens. And as of now, you have to understand we kept this 2 information. So I told that since it is a key value pair, key is 1, value is this, key is 1, value, key is 2, value is this. So this 2 key value pair is kept in the Hazelcast member. We are not looking at what system you are putting it. How could I explain it? See, member 1, understand it very clearly. Member 1 is there, member 2 is there, member 3 might be there, member 4 might be there. Anybody who writes data, it might be a Java program. If you want to write it into the cluster, you might not be connecting to any of the individual member. You don't be bothering about what member you are communicating. You will be bothering only about a cluster. So on to the cluster, you write the data. It might be reaching M2 or it might be reaching M1. No matter to which member you write, automatically for other members, it will be distributed. Suppose if you are reading the data, you're trying to get the data from M3. So for example, if you're looking for a key called 1, at that point of time in M3, that partition might not be there. It will be making requests for other members whether they have it. Only when no member has the data, it will be responding that it is not found. Otherwise, it will get the information from other members. That's how the Hazelcast members work. So if I run it for the 3rd time, same customers, I'm going to add 3, 4 also. And even 2 more data items I'll add. So now totally it will become 6 items, 3 members. Already 2 members are running, isn't it? So please observe this stuff properly. And so far we haven't talked about caching and all. We are just in the process of understanding how the cluster behaves. Next step I'll tell you about caching. So right now 3 members are part of your Hazelcast cluster. And now I go there. See, 6 members. It is distributed across the nodes. 3 has 3. This is having 2. This is having 1. So the information is distributed between the nodes, and number of members is concerned. There are 3 members. And suppose if I stop one of them here, if I put down, let us stop the 2nd member. Will it erase the data which is put forward by the 2nd member? Definitely no. All 6 members still will be intact. So I'm going to stop one of the, I'm pressing the red button. I already pressed it. So it has become 2 members now. I think I have deleted the 3rd one. So now I go here, members has become 2. And as far as maps is concerned, it would have been redistributed. See, it is equally distributed now, 3, 3. Earlier it was 1, 2, 3 or 2, 1, 3, I think. Now it is equally redistributed. So there is no point of losing the data at any cost. So if a member is getting stopped, automatically the replication will be in such a way that at any cost, the data will be available across the cluster members. Only when you delete all the stuff, then it's a problem. So we have built a server, and in fact right now there are 2 servers running. Just 1 minute, only 2 minutes before we let us logically conclude this point. Before we go for the break, I'd also show the client. So this is another program altogether. Even client can also write information. Okay, it's my mistake. I was wondering the program is different, but it loaded in the bottom, it seems. So this is the client program. So look at this. What I'm doing is I'm just creating client. Don't use the function instance. You're just creating new Hazelcast client. What you're trying to do is you're trying to get the value of key 1. Let us see what happens. Run as Java application. So only 3 lines. In fact, the library is same. And if you want to end the client, you can use the function client.shutdown. See, value has been retrieved. So in the customer's map, the value for key 1 is this. So this is how we retrieve information from the client. And this is not a member. This is just a client. Client is different from a member. It will not have any port number occupied and all. This is just meant for reading and writing information. Even you can write information also by using a client, but it is definitely not a member. All right. So this is about creating servers programmatically and accessing data by using Hazelcast client. We have understood about how to invoking the cluster members, and the example which I have given is an embedded way of deploying application. That is, we are creating a Java application. As part of it, we are building a Hazelcast member. So the moment we run it, the member is getting added in the cluster, and we clearly observe that whenever we are stopping one of the member, automatically the data gets redistributed, isn't it? So these are the various data structures that are possible, but as of now we are playing with map. And before I go further, let me try to write information by using client. So if we explore the number of programs right now running is only 1. I terminated the other stuff. That is, only 1 server is running. So that too, it is not a member. It is just a client. And let me go and check here. under maps. See, earlier there was 6 entries, right now there is 1 entry added. So my point is, what I want to put forward is a Hazel class client is different from an instance. A client is never an instance. So to create instance, we'll be actually using the function called new Hazelcast instance, whereas client is just a member which reads and writes data. It is not part of the cluster always. We just use it for reading and writing information. And as I told, still we are not into the caching process. We just understood how to add members into the cluster. All right. So all we have seen is an embedded member into the cluster. And as I told, if you want to run an independent member, you have to download that Hazelcast zip, open it, and run the batch command so that the server will be started by default on the port number 5701. If there is any member already existing, it will add a new member. So even if you run it outside, it is also a Java process. That's what you have to understand. So this is about creating Hazelcast members and forming a cluster. So in this case, all this belongs to a local system. But in general, if you are in a virtual network, you can run members across the systems and you can form it to be one cluster. All right. So next, practically, I'm going to show how to implement a cache, and that too I'm going to explain it with very simple example. No complications involved, because since we are exploring multiple things, let's keep simple at each level. First, we understood about cluster and building a cluster, and we've seen how to write data by using a map example. And now let us understand the thing which we've been talking for the past 1.5 hours, that is about caching. So before we go programmatically and understand, these are the various caching patterns which one can implement. That is read through, write through, and write behind. So implementers can follow these 3 different methodologies to take care of caching. So the first technique is read through technique. So in read through technique, usually what we will be doing is we'll be using the cache only to read the information very quickly. So you load the information periodically from your database. And for the question, can we periodically refresh reading from database automatically? Yes, it's all about your configuration. So we can periodically read information from the cache into your from the data store to your cache. And how your deployment basically works is, so in your application, for example, let us assume you have an employee table, employee number, name, city, and so on and so forth. So let us assume 1, 2, 3, you have records for that. What we might have done is we might have read 1, 2, 3 records already. So we might be maintaining a key 1. So this is the object for it. 2. This is the object for it. So it might be maintaining the stuff in the cache. So when somebody makes a request for a data item, for existing keys, it will check whether the data is already there in the cache. If it is there in the cache, directly from here it will be writing information. In case if it is not there, it will make a fresh read request to your data stores. In case if that new key is available, it will fetch the information. In case the key is not there, obviously cache cannot be filled. So only when there is no match in the cache, it will try to fill up this. And here in this case, in this strategy, we are not looking at writing information into the cache at all through the writing information into the database through cache. If you want to write information directly, usually you'll be writing it directly. Here we are using it only for the read purpose. So this implementation is there for many of the things, because if you are too much concerned about consistency of the data, if you play a spoil sport in the implementation of cache to database, it might cause problems because of the delay happening here. So the overall consistency of the application might damage in case the implementation is not right. So write through has to be worked out appropriately. The most common technique that is followed is reading the information, keeping the information in the cache, and as and when a request is coming, if the information is already in the cache, providing it to the application. And here the information will be spread across multiple Hazelcast nodes. This is read through technique. Another technique is two techniques for write through. And I remember one of the questions, what if my database fails? So here this is a synchronous technique. Write through technique is basically synchronous in nature. So according to this technique, whenever an application is producing some data, for further reads, what we will do is we'll keep the data in the cache itself, and parallelly the copy of the data will be stored into the database. And suppose from the next time onwards, if somebody is requesting for the data, you don't need to go for the database and fetch it. It will be available here itself. But the point is, since it is implemented in a synchronous mode, the performance of the application, the throughput of the application will be impacted, because how it works is when somebody puts a new value, it will be reaching the in-memory database. First, it will be filling up the cache. Parallelly, we'll be trying to write it to the database as well. Suppose at this point, if it fails, the transaction is not said to be done. So until this whole process is done, you will not be even taking up the new transaction to be performed. So obviously we have to wait in this case. So it impacts the performance. So there are two kinds of write happening each time. First, it has to be written in the cache, then it has to be written in the database, and the whole process is considered to be one single transaction. And one single transaction has to happen in one go. Otherwise, the whole transaction is said to be failed. So obviously, since two or write operations are involved in this case, because it is synchronous in nature, the amount of process that is happening is more. So obviously, it will impact the throughput, but it will be better on consistency, right? So that is write through option. So the name itself is implying. So we are keeping the cache and the data store in sync with each other. If you are adding new data, it is not directly added to the data store, it is going through the cache. So obviously there is no point in missing any data. They are in sync with each other. The other technique is, since from here to here, when you are writing data, until this process is finished, you are not taking up the another next transaction to keep consistency in mind. End of the day, it is, you have to understand, it is grid infrastructure. That is, request might be coming from multiple ends, isn't it? And the application also will have multiple replicas. So adding one more row or updating the same row will take time unless or until the first transaction is finished. For example, the record one, key one, if you are updating, same request is coming from other person, means only when this transaction is finished, this guy can work. So obviously it will impact the consistency. Even the cache will not be available until then. But whereas in this case, asynchronous case, what happens is, first it will update the cache. It will not be immediately updating the data store. So it will be running a background process with, that's what we told, eventual consistency. So in the background process, constantly it will be updating the data store, but the cache will be available for consumption from the end user. So immediate write operations will happen on the cache, but in the original store, there will be a slight delay. So configurable delay, and the process is asynchronous in nature. But how you choose the technique is completely based on your business scenario. If you are looking for availability, choose technique number 3, that is write through caching. If you are looking at consistency, choose technique number 2, or otherwise if you are looking only at the read operation, choose technique number 1. So these are the various things which are infused in caching your data. So we have talked enough on caching, and right now I'm not going to use any database and build a cache layer, considering time and other stuff, database connection and other stuff into consideration. What I have done is I just assumed that there is some database layer which is providing data to the application. So I hard coded the data, yet I'm maintaining cache. So I'm going to explain how caching works, particularly in Hazelcast and Java combination with the help of an example demo. So let's move ahead and understand how caching works. Then we'll talk about the other stuff like messaging and streaming. All right, so up next, as of now, we discussed about the various cache access patterns like read through, write through, and write behind. So write through is suitable if you are looking for consistency. Write behind is used for if you're looking at availability. And so let me go ahead again with the example. So I have another application defined called Hazelcast Cache. So if you are not into Java background, if you are from some other background, don't worry too much. Here this is a Spring Boot application. I simplified it as much as I can. So this Spring Boot application, let me close the other stuff, whatever I had. Even if it runs, it doesn't. It's not a problem. But I have closed everything. So there is this server port 889 which runs a web application, right? So in that web application, all I have defined is a simple API, a REST API with two endpoints, an endpoint called hello and another endpoint called search, for which I'll be sending a pattern, right? So for example, if I call the URL like this, let me define the problem so that you can understand how a real-time problem could be. HTTP, the URL is localhost because it is a local deployment. The port number is 8899/API/hello. If I give request for hello, it is just going to tell hi, Spring Boot is running. The second case is search, same URL. If I'm giving search, let us understand I'm searching for a product, say Apple or something. So let us assume this product needs to be searched in the database and result need to be fetched. So obviously searching the database, fetching the result will take some time. So very first time anyway, it will fetch from the database. From second time onwards, it will be maintained in the caching. That is the technique, right? So in this example, I haven't put database in place, just I hard coded the searching functionality without putting database in place. But in real time, you have to understand there might be a database which might be yielding the result. Very first time anyway, it will be fetching from the database. From second time onwards, it will not. So that is the case. So this is the API code. And what else we have done is the starting point of this program is this. It's a Spring Boot application. And only one thing, Spring Boot is a very, very handy technology. You can avoid writing a lot of code and you can avoid writing a lot of configuration as well. I haven't told that I'm using Hazelcast or anything. I simplified the stuff. I just kept enable caching. But how this technology knows that you are using a particular hashing technique is we have this starter project. So this starter project, any caching technology, be it Redis or be it Hazelcast, if it finds any cluster, it will be able to store information on it. But in this case, according to our configuration, we have configured a Hazelcast cluster. So our network is based on Hazelcast. So I used a YAML file that our network is Hazelcast. So we put this. And let me go to the controller once again. Here, look at this. Whenever the user is searching for a pattern, what I have done is I used a service object. No, those who know Spring might be knowing it. If you're not aware of Spring, don't worry. I have a service object. In that, I'm calling a function called getItem. So I'll be passing the pattern to get the data. Once I get the data, I'll be returning it. So what I have done in the service is, this is getItem, isn't it? So this function itself I have made cacheable. So the cached collection is, the name of the collection which I'm caching is items, right? Perfect. So next time, same string passed, in the sense it will not be calling this function at all. It will be taking the value from cache itself. So that is what the beauty of this annotation is. I have just used cacheable, and name of the collection in which the data will be stored is items. Very first time I will take the string and I'll call the search item function. So you have to imagine, in the search item I'll be doing database operation, but here in this case I just return the value directly without any database connection, but you assume that you'll be doing some database process here. So whenever you make a search request here, this function would be of course running, but second time onwards, if you are calling the same item, surely it will not run the function. The old result will be returned automatically. And what I'm doing is, just to know there is a slight delay in searching the items, intentionally I have stopped the thread to run for 5 seconds, then only I'm returning the value. So directly if such item is called, there will be a delay for 5 seconds. Right, so that you know the difference between caching and non-caching, right? So if the search item function is directly called, only after 5 minutes you'll get it processed, right? So this is how the setup is. Let us run the application. This is a microservice. You don't need to deploy it anywhere. Directly you can run it. I think I have put forward the scenario correctly. Once again, I'll tell you. So there is a REST service which has a URL, API/search, and you'll be entering a particular product. Imagine this product to search in the database and providing the result. It might take some time. So I want to cache this search information. Suppose second time anybody searches the same information, instead of going and fetching from the database, we'll fetch it from the cache. So hence we put cache into place. So for that, we enabled cache in the application, and the function which you are making here has become cacheable. Second time onwards, if you pass the same parameter, it will not be running the code again. It will be yielding the old results. For that, we have configured a Hazelcast cluster. That is the overall idea, right? So let us run the application. So it has added a member into the cluster 5701, and right now I go to this and I do find a member, right? And there is no storage at all as of now. So I told the URL is what? According to the code, you have to give API/hello API/search, isn't it? And the port number is 8899. So what I do is I go to the browser, localhost 8899 API/hello. Perfect. It says Spring Boot is running. This is not a cached information. It is no problem at all. The second URL is, what is that? Search. My simple doubt is whether it is in small case or uppercase. Yeah, small case. Search slash, for example, API slash search. Let us think that I'm searching for a pattern called India. All right, so let me run it. Immediately you're not getting the result. It'll take at least 5 seconds to get it processed because I delayed the process, isn't it? So only after 5 seconds I'm getting it. Even for that matter, let me put another such string, Chennai. It takes 5 seconds because assume that very first time it is calling the original function. And let us go to the now a new map is added. Look at this. Items 2. So 2 items are added. So that is a cache is being maintained in the form of map. Have we written any code here? No, automatically it is happening. That is the beauty of Spring Boot. It is tightly integrated with Hazelcast. So automatically the cache layer is working. So right now, even if I'm going for a different browser, here also I can refresh it. So next time I refresh it, see it is coming immediately. But you might wonder it is because of browser cache. That's why I'm going for a different browser. Even here it is so fast. So that is the importance. If you remember our discussion right from the beginning, I told that browser cache is there and server cache is there. Application cache is there. So if you are maintaining a browser cache, only to that browser it will be confined. And if you're using a server cache, only to that server it is confined. But if you're using an application cache, no matter who is making the request, using any channel you make the request, still the cache will be maintained, isn't it? For the second time, it is processing so fast, regardless of the browser you are using, regardless of the place you are using, because Chennai is already worked out. And even India, if I give it in this browser, it is going to be fast. And if I go for a new string, it will take time because it's not searched before. There is no data in the cache yet. And here, if I go to China right now, the other browser, very first time, but still it is very fast here because the cache is not part of browser in this case. The cache is part of the application. So a cache layer is automatically maintained at the application level. So operations which are taking time, you can maintain a cache of it and you can maintain a cluster. And in fact, based on the load, you can keep on adding nodes for it. So as I told, right, if you remember randomly, I told that if you are maintaining, because you need to technically clear about certain stuff. See, I have a Java microservice running, microservice 1, microservice 2, and I have member 1 and member 2, which is embedded in nature, and you should not misunderstand that embedded cluster cannot be connected with other application. Still, even though it is embedded to these members, even other language applications can also interact. Likewise, here in this case, already this Spring microservice is running. Parallelly, what I do is I run an independent application, which is nowhere related to the current application which you are running. But in that application, the code, whatever we have is having a new instance, isn't it? So let me uncomment that. So if I run this code, the second member is added. Even see, even in the Spring Boot application, if I go and check the log right now, this is also impacting. So that to the cluster, any new member found, it will be getting notified. It has included that into the cluster. So you can add members into it at any time you want. If you deploy a microservice, you can embed a new member and you can make a grid out of it. Hence, this way Hazelcast is so different from other cluster environment, because in other cluster environment, you have to go for a private deployment, which is not part of any running microservice or stuff. They'll be running independently and they will be forming a cluster. Whereas here, since it runs in the embedded mode, for every program you run, you can associate a member with it. It can get added with the cluster. So you can use even a minute of space. So this is a perfect horizontal scaling. Everywhere you run something, you can make use of the space whatever you have. That is the advantage of running it in a embedded mode. So right now, if you go here and check 2 members, and as far as this map is concerned, 3 members are added, and look at this. This is distributed across 2 nodes. So even though application wise they are not related with each other, yet the embedded cluster members, they are splitting the members, I mean data among themselves. Even though this Hazelcast server is no way related to Hazelcast cache application. Application wise they are completely independent of each other. But since both of them run a embedded Hazelcast member, the data is shared across them. Suppose if I stop one of them, I go for this one and stop it. And if I go here, no loss of data. Still, the remaining member is holding all the data items. So if scaled, the data will be spread across. If compacted, again, the data will be readjusted accordingly. So this is about caching your information, and further advanced about it, it's all about implementing various strategies about it. I just want to give you the essence of it, how it is implemented with a simple, very simple example. If you bring in databases and the write through strategy, read through strategy, write behind strategy, everything can be implemented. So parallelly, as someone asked, can the data gets refreshed automatically? Yes, strategically you can manipulate any kind of requirement as far as caching is concerned. So I just want to rest my case on caching at this point. So I put forward step by step. I explain what is caching and what is application caching and what is a Hazelcast in-memory data grid, and how we can capitalize that in-memory data grid for application caching. And I just explained it with a very simple example. So this is about caching, and further let's move ahead and look at what messaging is, what streaming is, and finally we close our case at understanding Hazelcast Cloud. 3 items. Okay. So the next set of points which I have told is, I right from the first hour I've been constantly telling cache is one aspect. This is the major use case which one can use it for. And second, it can be used for messaging. And third, it can be used for streaming. So the next aspect I'm going to look at is messaging, and again also I'm going to give a very brief example about it without complicating things. So first of all, we need to understand the messaging system, distributed messaging system in particular. So as someone has rightly put forward, there is IBM's message MQ, there is active MQ, there is Rabbit MQ. Many message queues are possible. They use or they follow the specifications provided by JMS, Java Messaging Service. So according to Java Messaging Service, the idea is, if there is an application component, if there is another application component in the distributed environment, and if there is one more application in the distributed environment, some event which is happening here needs to get notified to the other applications. There might not be direct connections between these guys, and it is not essential either. So how can I communicate with all others that something has happened? So what we might do is we might deploy a messaging service. The best example is in any sector, it is fine. For example, particularly in banking sector, you might be using mobile banking. And you'll have a mobile application deployed. You might have personalized it. And for example, there might be an application, for example, ATM machine, which is again an application. It's a different application altogether. You might be performing, an end user might be performing a certain operation with the ATM machine. And the database is getting updated through a microservice. You are processing it. And no sooner you perform some operation, you might be getting a notification to your mobile banking account, and you might be a notification might be popped up if you have subscribed for the notifications, notifying that something has happened in your banking account. That means without you going and checking it, automatically this guy is getting notified because of this guy. Another you may be the same person, but the point is you are using two different user interfaces. One is an ATM machine, another one is a mobile. So the interaction is happening with an ATM machine, but the other point which is getting notified is your mobile application. So how it is happening is when something is happening at the data level, this information is passed to a message queue, and point-to-point communication is established between this application and this application, and the connecting point is message queue. So in this particular account, whoever subscribed to that in the mobile application, a notification is being pushed. So this is one example which I'm providing. There are hundreds, even thousands, or even millions of use case scenarios which is used in every industry. For example, YouTube's subscription model. So if you subscribe to a channel, whenever somebody posts a video, automatically others gets notified. Everywhere this model is, even in case of if you travel in Ola cab, you book a ticket until you book a cab driver. Until you book a cab driver, it is fine. Once a cab driver is confirmed, from then on his Google location is coming to you. That means constantly that guy is pushing his geolocation into the system, and constantly that location is established a point-to-point communication with you, and you are constantly getting his geographical movement. That is also a queue functionality, one-to-one. If it is notified to many people at the same time, it is a topic functionality, but both the cases it is messaging in picture. So application, two different applications, a central point, one of them would be publishing the information, another one will be subscribing to the information. If it is a point-to-point communication, we'll be using a data structure called queue. If it is publisher subscriber, that is one publisher or many publishers, no matter. Here it is specified as one to many. It can be even many to many also. Multiple subscribers in the sense you can go for a data structure called topic. So generally for notifications or constant communication between two applications, going for messaging services is inevitable. But in earlier cases, few years back, the model which we used to do for this purpose is client server model. You might have deployed a messaging service in one single point, maybe a server, which we used to call a messaging server. So one application would be pushing the information, that is publishing. A subscriber, one subscriber to two applications might have subscribed to it, so they will be getting notified. But the point is, the server is the point where the topic would have been configured, and the topic would be notifying to multiple people. This is fine as long as the load is less or the number of transactions is less. But for a system like a banking system, or for a system like a cab system, whatever the examples which I have given for that matter, even YouTube or many system which is big in nature, you cannot go for client server environment. We have to go for a distributed setup, and that distributed setup should be good enough in tackling the messaging also. I mean, the distribution of messages should also be between the system, the memory, everything has to be shared. So there must be a cluster of servers which is dedicatedly working for messaging, whereas in previous cases it is one server which is dedicatedly working for it. So that's where you might have heard about Kafka. It's a very popular thing. There are many distributed messaging services comes into picture, which plays a very crucial role in tackling large volumes of message exchange. So in a distributed environment, if you want to have a message exchange with the available grid layer, you can still use Hazelcast also for that purpose. You don't need to go for a separate setup for it. Hazelcast in-memory data grid itself will let you work as a messaging system. That is, you can create topics in the members and you can write information into the member and it will notify to the other clients. So to conclude, the topic meaning, that is messaging system, all you need to understand is a messaging system is something which acts as a mediator between two people, that is a publisher of information and a subscriber of information. For example, in a Ola cab booking scenario, the publisher is the driver, that is you are getting his geolocation, right? The subscriber is you. And even in YouTube, the video who posted that video, the user is called as publisher. You are getting notified, you are the subscriber. So if there is one publisher and one subscriber, if it is a point-to-point communication, you deploy a queue in place. And if it is one-to-many communication, you actually go for topic. So generally, if it is in client server mode, the deployment is different. But if it is distributed in nature, if it is too many messages to be exchanged across, you'll go for distributed tackling of messaging. So we can make use of an Hazelcast IMDG itself for this purpose, because internally Hazelcast supports messaging also. You don't need to go for any additional setup. So even in the demonstration, you will not be doing anything new. We are going to do the same thing, just programmatically we'll be pushing the messages, programmatically you'll be subscribing it and getting the messages. Additionally, architecture wise, you're not going to add any new component. All you got to understand is this is an inbuilt feature of Hazelcast member by default. All right, but I just want to put forward what messaging is. Most of you must be knowing it already. In case if you're new to this idea, this is what messaging is all about. Same thing. One of the node might be pushing the message. Other nodes need to get notified. Based on that, the application which is connected with that might be behaving. So in the cluster, a topic can be created. So it supports distributed message. So this is about the topic. I'm going to go into hands-on and explain it with a very, very simple example. Then we'll go for what is stream processing. And I want to reiterate one thing. In the current industry, you must be already knowing everybody looks for three things. They want things to happen on distributed mode because volume is growing day by day. Every business has large volume of customers. Earlier, customer had the patience of coming to a place where information is, so that we can manipulate in an appropriate way. But right now, we have to make the customer get the information because he has mobile in his hand, multiple mobiles in his hand, and at the same time he is working with his laptop, and at the same time holding the mobile he is going to ATM machine. So various information sources are there. So he is interacting with our system always. So one customer itself is getting connected with us with n information sources. You can imagine how to tackle millions of customers. So obviously without distributed processing, tackling the information overflow is impossible. So when you are doing it to satisfy the customer, obviously we need to look at better latency. I mean low latency and high throughput, processing large volumes of information in low time. So if that is the case, one of the common solution is we have to infuse not just I won't say it is the sole solution. One of the key solution is caching, and the third important thing is communicating from one point to another. So this guy will be interacting with one endpoint. another endpoint needs to notify it for that. So messaging is inevitable. Hence messaging systems are so popular. And every project, there is no project without messaging system in place. And then streaming, we'll talk about how streaming is also important. So all this plays a very crucial role, and there are dedicated projects for softwares for each and every individual purpose. But since there is an appropriate technology in place already in Hazelcast for building a proper cluster, they infuse the messaging into it naturally. But if you ask me about volume, it's always a question mark. You also need to understand about pros as well as cons. The problem with volume, because end of the day, each member is running on a JVM, right? It depends upon the JVM size, the number of nodes which you run. If you are, for example, in many messaging system, they will be even transferring GBs of files. Such kind of implementation, whether Hazelcast could tackle, it's a question mark. As long as it is minimal messages, it will work effectively in a distributed mode. Systems like Kafka and all, they are good at tackling information in volume also. But here it's all about tackling it in terms of distributed processing. But as far as the volume of information is concerned, it's all about our JVMs and number of nodes that are running. And certainly it is not good for tackling large files and all. It's just object exchange. It will be very good. Let us practically go there and explore, and then we'll move into the other step. Okay. So cluster details members 1, and look at this. There is no queues, no topics. So it also has embedded messaging stuff in it, right? Queues and topics. There's nothing in it. So again, as I told, I simplified it just with 1-line and 2-line code. Hazelcast server. Look at this. I stopped even the one node that was running. Right now there is no node. In fact, there is no cluster in place. So the listener is also a member here, right? And it can be even a client also. That it is not essential that a listener should be a member. Listener here is nothing but a subscriber. So first of all, even before creating the publisher, I'm going to create a subscriber. Okay. So I have written a subscriber program. So by using this Hazelcast object, I created a new Hazelcast instance, and I'm trying to get a topic. Earlier we used to get a map. In this case, we are trying to get a topic. I called it messages. In fact, it's not always about text messages. You can also share files, as well as you can also share there is streams, to be precise. You can also share objects also. In this case, this message is going to be a string message. Okay. So by using this topic, I'm not going to send any message. I'm just adding a listener. That means I want to listen. That is anything happening in this messages topic or not. If something reaches this messages topic, I'll be getting it because I have added a listener on message. Suppose if a new message is added into the topic, this application will get notified. So what it will do is it will just print message received, get message object. And will it run continuously? Yes, it will run continuously because it's an instance, right? So this is a receiver program. This is not a publisher. This is a subscriber. Run as of now, I call it instance 1. Let me run it. So 5701, one member is part of the cluster. So even though the topic doesn't exist, it is putting messages there. Even though there is a subscriber without a publisher, doesn't matter. When somebody is looking for messages into the topic will be created and it will be waiting, right? So one member is there. All right, now what I do is I go for another program. Shall we run another instance of it? Run Java application once again. I mean, I'm run. I want to stop it before it starts because I just want to put instance 2. Run as Java application. Second instance also. This is also a subscriber, not a publisher. So look at this. 2 instances are up and running. 5701 and 5702. Now what I'm going to do is I'm going to go to the server. So new instance, this time I'm getting the topic, but I'm publishing it. I call it, this is my very first message. Let me publish one more message, my topic. Publish. This is my second message. So here this member is coming. This member guy is a publisher of information. Let us assume his this server is notifying the other members. So let us run it. So first it needs to join the cluster, then it needs to send the message. Let us see. So third program is running. So it has joined as a third member. So look at that. I go to instance 2. So in instance 1 also it is received. And also in instance 2 it should have been received. Yes. So because it is a topic, so whoever subscribed to it, everyone will be getting it. So the program is demonstrating a publisher is publishing it. A topic is there. There were 2 subscribers, member 1 as well as member 2. Both are getting notified because in the print statement you found the message received appropriately. So the moment a topic receives a message, all the subscribers will be getting notified. In real time, multiple microservices will be there. From one microservice, you might be pushing the information. From other microservice, you might be consuming the information and you'll be taking an appropriate action based on that. So in the topic, we have 2 messages received by 4 members. In fact, 2 members received is 4 because there are 2 subscribers. So 2 into 2, 4. So I just demonstrated the functionality provided by Hazelcast internally, which has naturally in it. You can utilize it for even messaging also. So that's what I'm trying to put out. It works in distributed mode. So this is about Hazelcast messaging. So first one is caching. We talked enough about it, and then messaging. We understood what it is and how practically it works. The third one is about streaming. This is also one of the very common aspects which we go for in applications, which is a popular thing in work, particularly distributed processing. Let me put forward the idea. Let me look at the picture which is appropriate. Yeah. So no matter what, in most streaming systems, any streaming component will be basically an application layer, to be precise. It's not a server or a distributor information, but somebody who provides information to this may be a distributed environment. So what exactly is this is you have to understand in real time, that too in the world of big data. Information is constantly produced at various sources. As mentioned here, it might be an IoT information, or it might be social network information, or your database information, even the information which is part of, that's why I put an arrow mark here earlier. Even in your grid, information can be produced, or in your Hadoop system, information can be available. So constantly when information is getting produced, right, what you might be doing is you might want to move that information produced from one source, get it from the source, process it. Don't misunderstand that I'm mixing up all the data getting from all the sources. It can be any of that. That's how you need to understand it. So process it, apply your business logic, scenarios are many. For example, even if your logs constantly, an application might be writing logs. In log, automatically what will be there is time will be there, thread name will be there, the outcome will be there, but it is a text file. So you may want to read the text file. Within seconds, millions of log records might be coming. So so what we'll be doing is we might be building a messaging system. The moment a log is happening, you might want to stream that to the streaming system. So automatically what happens is it receives the log, it walks through the log, and it will separate the time, it will separate the thread name, and it will separate the issue, and it might refine the information, and it might create a table out of it. Maybe it might be the application might be visualizing it, that is number of logs that are happened, and what areas, how many records that are stored, and what areas that are affected. So you might be providing it on a visual medium. So getting the information, processing it, moving it to one more resource, that is as specified here. It might be moved to an application, or you might be generating alert out of it, or it might be storing the information in a database. So one step extended to messaging. Messaging is just receiving the message and passing it to some other source. That is a different aspect. One more extension is getting the message, processing it, refining it, making it more meaningful, and moving it to one more source. That is what we call as streaming the messages continue. And messaging is it might not be that constant, whereas streaming will be continuous. As I told, logging continuously, you will be getting information on an information source, and you will be continuously processing it, and you might be moving it to one more source. So in technical terminology, usually they call it source from which you're getting the information. In the middle, you are running a job, and then the information is moved to a sink. The destination is usually they call a sink. So even Kafka has this process. You might have understood about Spark. So these are the various popular technologies which work in this streaming area. Even Hazelcast has its own streaming solution called Hazelcast Jet. So Hazelcast Jet is again an application layer which can be embedded with your IMDG for storage. And what it does is you can connect this Hazelcast Jet with an information source. You can receive information from any information source. You can process it, and you can write the results into any of the information source again, which is a sink. So you have to understand Hazelcast is a very, very effective solution because it has libraries to get connected with major information sources, like as we have mentioned here. It can connect with Azure, it can connect with AWS services like S3 bucket, or it can connect with flat files, it can connect with databases, it can fetch the information, it can process it, and it can move it to other source. That is the conceptual idea behind any streaming system. Hazelcast also supports it with a component called as Hazelcast Jet. So I've been putting forward all the features that are available. So as and when we have a use case which we can make use of it, we can put it into work. Here I'm going to again go with a very simple example. In fact, I haven't even created it. I just made use of the official documentation from Hazelcast. I'm just going to demonstrate. They have a perfect documentation for various use cases. For AWS, they have an example. Look at this. For sample, I have examples, but I'm not showing up all the things right now. But I want to tell you, for reference, they have a large volume of Hazelcast Jet. Look at these examples. They have examples for various use cases, playing with files, playing with cloud, connecting with Kafka, working with other languages, information from through sockets, various things. I have just taken one example, even Hadoop connection. So as far as documentation and information is concerned, Hazelcast has a perfect documentation, and in fact, they give a perfect worked out project for understanding it. So that way, Hazelcast, in terms of documentation and use cases is concerned, things are perfectly in place. So here I have this example called word count. Just I want to demonstrate the things which I have practically just told. As I told, it's an application layer. You don't need any deployment, or it is not a cluster or something. It is an information processor. That's it. It's not going to impact your IMDG cluster because it's a different component altogether. So this is the form.html file. See, we have Hazelcast Jet. So this is the library. In earlier case, it was Hazelcast all. This is Hazelcast Jet, which is a separate programming component. So if you have this component, what you can do is you can configure a source, you can build a pipeline, and you can reach it to a sink. Always remember, three things will be part of any streaming system: source, sink, and the pipeline, whatever you're building. So look at this. So we are creating a Jet instance. Where am I creating it? Here. So I'm just setting it up. And what I'm going to do is I have some information source here. Rather going to other cloud sources, we have a set of books which is in the form of text. But you have to assume in real time it could be any database. It might be Cassandra, or it might be any NoSQL database, or it might be from MongoDB. So any information source. So here we have specified the folder book slash, and by using buffered reader, we are reading the books, and by using Jet, we are getting the book lines and putting all the lines into the map. So here we have a result map which is created. And what exactly the process which we are going ahead is, go is the function which you are calling in the main. So in the go function, you are building the pipeline and you are creating a new job, and to the pipeline will be always specifying the source, and whatever the job which which pipeline is giving, that job will be run, and finally we'll be checking the results and printing the results. So in the result, we'll be reading the map and we'll be showing the result. So I'm not getting deep into the code. I just want to tell you the process. That's it. So in the pipeline, we are reading the file word by word, and the delimiters usually will be space. So what we are doing is we are running this process to run the word count from the files. So the aim of this is specifying a source and specifying the sink. Here the sink is a map. So we are reading data from a set of text files. We are counting the words word by word, occurrences of the word, and we are putting it in the map. And from the map, we are reading the values and we are checking the results. This is our part, but as far as the job is done by Jet. So let us run this. So it is looking at the words and number of occurrences of it in all the files. So it will go to the folder and it will do the word count. So it is yielding the result in a map. So in the map, the information which we are showing us, let me run it once again. If I go deep and explain the program, time would be consumed, but that's why I'm just giving an overview of the problem. So the source is set of text files, and the result it is yielding us the number of lines and stuff in the program. So these clusters are disturbing it. 1 second, let me close them. Now I can go to the main program and check the output. So what it is doing is reading data from the source, processing it, and usually the sink here is a map, but you can move it to any database like count word can be probably placed into another information source. So this is how Jetstream works. Any streaming system for that matter, it works in that way only. So you need to build a pipeline. You need to say what is the source, what is the destination, and what the job is being done. And any system by default will have a default example for word count. But in real time, what we'll do is we'll get the information, say a record, and we'll be reading the record and we'll be checking the nature of the record. We'll be processing it according to our business scenario, and we'll be moving it to one more place. So it is as I told, it is an extension of messaging. In messaging, what we'll do is from a subscriber, we get the information. Directly we pass it to the, from a publisher, we get the information, we pass it to the subscriber. There is no processing involved. But continuously, if an information source is producing information, if you want to constantly read it, process it, then if you want to move it to a sink, even for data migration from one database to other database also, you can do it. In fact, most people use that for that purpose. So you can capitalize it for any real-time scenario. A streaming system can be used. In Hazelcast, Hazelcast Jet is the product. So that is about streaming. So the last and final thing is, we have seen so far it's all about on-premise deployment. I haven't used any cloud cluster which is built ready-made and used. I just shown everything in our own programs and our own deployment, but they have come up with a product called as Hazelcast Cloud. And the memory as well as the storage requirement, they are internally using AWS, Azure and Google Cloud as various options. So while creating the cluster itself, you can either go for AWS or Azure or Google Cloud. It's up to you. So on top of it, they are running the Hazelcast enterprise cluster members on Docker containers, which are managed by Kubernetes. So Kubernetes is a container management or container orchestration utility, where on Docker containers they are running Hazelcast members, which is perfectly orchestrated, and the cloud has a proper dashboard to understand about your nodes and what data is being stored, and you can connect with the cluster by using any language. So in this, it's a client server model where we don't have anything embedded here. The cluster is in cloud, you can use it. So this is the architecture, of course. So the underlying Docker containers deployment and all will be happening in the cloud of your choice. It might be AWS or Azure or Google Cloud, but the consumption of that information can be happening in your on-premise by using any of these languages, and you can always get the information from the dashboard which is provided by Hazelcast Cloud. So it's not just a description. I'll be showing practically how this works. Hazelcast Cloud login. So I want to conclude this discussion with this cloud demonstration. So I already created a cluster. Very first time if you open it, I open it in another browser. Hazelcast Cloud login. You can sign in with anything. So very first time you sign into it, you understand, right? So here, so far whatever we have seen is an on-premise deployment. Programmatically we were deploying it in an embeddable fashion. So here they are offering a cluster which is created by them, so that anything related to management of the cluster will be taken care by the cloud itself. So as of now there is no cluster created here. I'm going to create a new cluster. They offer multi-node cluster or one node cluster, which is fixed 200 MB of memory. If you want to horizontally scalable cluster, they have other plans. As of now, just to demonstrate, I'm going to go ahead with the free plan. Only one node is possible in it. So the version of Hazelcast is this. If you want to enable encryption, enable IP whitelist, everything you can do. And here, since I want to consume it from my IP address, I can add my own IP address, so that only from my IP address I can make request and run my application. So as I told in the picture, you can go for any of the cloud services. As of now, they haven't enabled Google or Azure. Only AWS is available as of now. These two things are coming soon. So we have to choose an AWS region. Even here also they have only 2 regions available. As I told, it's a new service from them. IMDG is the original product initially, which they became popular. So we have already enabled everything, and pending. How long can we wait until it is pending? So I have an alternative here. I have already a cluster which is running. So if you get into the cluster, as I told, IP whitelisting can be done. Memory, anyway, there is no management of memory here because we are going to with the minimal plan. And you know that what data structures are supported in a cluster, so you can choose an appropriate structure to store your information. So as of now, if you want to get connected with this cluster, they themselves will be providing you a way to do it. So to give you a better idea, what they give is a sample application to get connected with the cluster. So I already downloaded this application and deployed. I'm going to show you how to work with it so that this cloud system will work as a cluster. So you can build multiple clients. You can use it as a messaging system, or you can use it as a cache, or you can use it for streaming, anything. That's up to you. So we have set up the cluster, and I already downloaded the application in my system. This one, Hazelcast Cloud Java sample client. So look at this, they'll be giving a token. So that token has to be pasted as part of your application that represents your cluster. All right. So all you're doing is you're creating a client. You can even you cannot create an instance, of course, because the cluster is already created. You can add members only there, or if you have a different plan using the library, you can add instances, but you have only one node cluster, so there is no option for you to add instances. So in this program, all you're trying to do is create a client using this configuration, and the cluster name is of course my cluster. And using the client, what you're doing is you're creating a map. If the map already exists, you're just putting some random content into the cluster constantly. All right. Apart from that, you're not doing anything. You're just putting information into the cluster. So let me run the Java application. If everything goes well, I have whitelisted this IP already. Otherwise, it will not get connected. So it says connection successful. Now the name map will be filled with random entries. So it is going to add entries into the current map says it's constantly keeping content into the map. So it's got connected, and if I go to the cloud and if I check it, there is a surge in the the dashboard is live. It was flat all this time, but suddenly there is a surge in throughput as well as entries also. So in the dashboard, the map, there is only one map here, and you can find the live entries of the map, and you also find the client details here. So you can play with multiple maps, and you can use it for your application purpose. So you can, all I'm trying to say is you can build a cluster on the cloud, and you can use it across various applications as a cache layer. So let me stop the program. So this is what I intended to put forward in this discussion. I want to just let you know what Hazelcast is, what are its capabilities, and as I just told, it's an in-memory data grid. When you think about data, it is always key value pair. The primary data structure which we use here is map for that purpose because it is Java based. And if you want to technically think about it, any Hazelcast server is a Java process which is running on a Java virtual machine. And the primary purpose is you can use it for application caching, you can use it for messaging, and you can use it for streaming. For streaming, there is a separate component called Jet. And when it comes to deployment, if you are going for on-premise, you have two options. One is client server environment, another one is embedded environment, and finally I introduced you a third product also called cloud. So you can also have cloud deployment. According to the plan you choose, you can have number of nodes and memory. So this is the best option if you are looking for saving memory or saving money, as well as if you have clear clarity on what you're going to do, we can look for a cloud option also. And practically we have seen how to implement caching, and also we took a very small example on streaming, and we also seen messaging. And apart from that, if you are having an on-premise deployment, you can monitor that by using management center. So within the stipulated time, whatever we have had, this was my intention. Of course, I put forward whatever I intended to present in this time to showcase the capabilities of Hazelcast. And it's all about getting deep in each of the aspects. Already a lot of questions trapped in your mind about caching. What if a database is down? What if a member is down? And whether writing happens automatically or whether we need to do it. So all the solutions are there. So every question which you got, the automation is possible, but it's all about how well you configure it. So only when you get in deep and we do more hands-on and stuff on that, we get to understand it better. But any practical question which you are getting in your mind, obviously there is a solution for that which is addressed already in the product. But this is the overall length and breadth of the product is concerned. So that's what is being intended.